So we have 6.4b today, which is more factoring. Now, the method that we're going to use today, I think a lot of the IM2 teachers call this the Super X, that kind of thing. I happen to call it the Snowflake. So if you think Super X and I think Snowflake, we'll all be good. Okay? My Snowflake might be slightly different. I'm not quite sure. But whatever method, if you remember how to use it and you're using it correctly, fantastic. Keep going with that. Okay? So, let's see. Let's do example 1. X squared plus 5x plus 6. So, I'm going to put Snowflake next to this. Just so that you know, when I say Snowflake, I mean this method. Is it Super X that the IM2 teachers call it?
Yeah.
Maybe you guys can show me how the Super X is different than my Snowflake. So, I start off with a big old X kind of thing. My X has a belt. That's what makes it the Snowflake. Do you guys put the belt?
Yeah.
Okay. What goes on the top of the Snowflake or Super X? A times C. What is A in this case? 1. What is C? And 1 times 6 is 6. What goes on the bottom? B. In this case, B is 5. Any questions about where I got those from? Because remember, we always have to remember that ax squared plus bx plus c. This is where we're getting the a and c from, and the b. That's called standard form for a quadratic. All right, so what do I need to do at this point? I've got two numbers. I need to find out what's going to go here and here. How do I do that? I need two numbers that will multiply to get me 6 and add to get me 5. Any guesses? Because 3 times 2 is 6, and 3 plus 2 is 5. We've got all positive numbers here. That makes life easy. What do I put up here? AX, right? A is 1, so I have 1x and 1x. Is that the same as the super x?
Yeah.
Okay. Last thing I do is I check to see, can I reduce this if it was a fraction? Can't reduce it. Same thing with this one. So I have two parentheses. What are my two parentheses? One of them is, the other one is that exactly the same as the super x?
Yeah.
Perfect. So my snowflake is your super x. Can I check to make sure my answer is correct?
Yes.
How do I do that? You would just multiply it. X times x is x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. And when I combine like terms, did I get the original problem? Yes, so my answer is correct. Remember, we're just unmultiplying here. Okay? Yay, I'm so glad this is the same as your super x. That's going to make life easier. All right, x squared minus 10x plus 25. What's going to go on the top? A times c, which is 1 times 25, which is what? 25. What goes on the bottom? Negative 10, my b value. What are two numbers that multiply to get 25 and add to get negative 10? Negative 5 and negative 5. Huh, okay. So what goes on the top then? A and x. A and x. What do you notice about these two things? They're the same. Now in IM2, I'm not sure if your teacher was okay with you writing it like this. But let's get one step a little bit more mature. And let's call it that. Okay? So I'm looking for that answer. This answer right here would be minus 1 point. Okay? Let's get all the way to there. Not too bad? All right, let me give you number 3 and you can try it. You know what? I'm actually going to give you number 3 and number 4. I want you to try both of those. All right, number 3, what goes on the top? And on the bottom? What are 2 numbers that multiply to get negative 6 and add to get 5? 6 and negative 1. Are there any other options that would multiply to get negative 6 and add to get 5? No. Every other combination will either make one of them negative that's not supposed to be negative or something. This is the only one that will work. 1x and 1x, so I have x plus 6 and x minus 1. I tried to keep today's relatively simple so that we don't have too much reducing to go on, and then tomorrow we'll have the reducing ones. Okay. What about number 4? What goes on the top? And on the bottom? Okay. What are 2 numbers that multiply to get negative 12 and add to get negative 11? Negative 12 and 1. Again, no reducing yet. So I have x minus 12 and x plus 1. Super easy, right? Try this one. X squared minus 11x plus 12. Very similar to number 4. What's the difference? The only difference is that this is positive. Let's see what that does. Two numbers that multiply to get 12 and add to get negative 11. Well, let's see. 12 is 6 and 2, 3 and 4, or 1 and 12, right? 6 and 2 and 3 and 4 are not going to get me 11, so they're no help. It's 12 and 1 are my only options, right? So if I put 12 and 1, the only way I could get negative 11 is what? If this is negative, right? If I'm adding, the only way I can get negative 11 is if this is negative. But if this is negative, do I still get a positive 12 here? No. So what does that mean about this? We don't write no solution, and I'll explain why probably a few times over the semester. We can't talk about solutions if we have a problem that has no equal sign. Okay? So what we have here is we have something that is not factorable, or you could say it is prime. So you could use either one of those phrases. It is not factorable, or it is prime. Okay? So? Okay. What if I had Let's see, 2x squared minus 22x plus 24. What would I do first there? Take out a 2, right? So if I took out a 2, what's left inside? X squared minus 11x plus 12? Yeah? Isn't this what I just looked at over here? Now this, I know I can't go any further. Snowflake's not going to help me, or Super X isn't going to help me. Does that mean this is not factorable? It was factorable because I could take out a 2. I just can't go any further at this point. So this one I would box my answer right here and be done. Does that make sense? Okay. I think I have 2 more problems. You ready? Call this one number 7. X squared plus 19xy cubed plus 84y to the 6th. Whew. Way to ramp up the difficulty, yeah? Now, picture this without the y's. If I took the y's out, I have that, don't I? That is totally reasonable. If I did my snowflake or my Super X on this, what would go on the top? 84. And on the bottom? So I need 2 numbers that multiply to get 84 and add to get 19. Let's see. 84, 6 and 14, does that work? No, that gets me 20, right? 84, not going to divide by 8. What about 4? 21 and 4, nope. 3 and 28. Did I do 6? I did 6, didn't I? 12 and 7. There we go. And then I have x and x, right? Now, how do I take this and put the y's back into the problem? Well, you know how we took the x squared and we split it up to x and x? What you're going to do is whenever we have this pattern of this exponent being twice this one, so if it was like 8 and 4, 4 and 2, 12 and 6, we're going to take this y and we're going to split it up. We're going to put half of the y's with the 12 and half of them with the 7. So I have y to the 6th. I'm going to put y to the 3rd here and y to the 3rd there. So what are my 2 parentheses? One of them is x plus 12y cubed, and the other one is x plus 7y cubed. So the x gets split up and put on top. Your other variable would get split up and put on the bottom. Not too bad? Good answer. All right, last one. Okay, so one thing I see is I see this. Do you see that? That fits the same pattern. So I know that whatever I'm putting into my snowflake, I'm going to have c to the 10th and c to the 10th here. Right? C to the 10th and c to the 10th. What do you notice about the a and the b? They're the same. So in other words, if I have a and I split a up at the top, I'm going to do the same thing with the b because they follow the same pattern. They both have a squared and then they both have no exponent there. This one's kind of evil. What are my numbers, though, that go in there? What goes on the top? 156. And on the bottom? So now I just got to figure out my two numbers there, and I'm good to go. Do you kind of follow that? This is really super yucky, but let's see. 156, what should I try? 8? Nope. 12 and 13? Woohoo, there we go. 12 and 13. How do they get negative 25 when I'm adding them? If they're both negative. Do they still multiply to positive 156 if they're both negative?
Yes.
Yes. So, what's my first parentheses? AB minus 12c to the 10th. And my second one, AB minus 13c to the 10th. Okay, that's an example probably because there might be one question on your homework like that. Okay, when we get into actually applying our factoring and stuff, the majority of our factoring is going to be more like these guys. Okay, so yes, there's a couple to challenge you on the homework, but when we actually get to graphing and using the factoring to see what it looks like on the graph, you won't be given crazy guys like that. Okay, all right, I will post the homework on Google Classroom. Happy studying.